Hi students, today we will discuss an important question regarding the equivalent capacitance of a particular arrangement. So to solve this question, we need the basic concepts regarding the parallel combination of capacitors and the series combination of the capacitors. And when there is a circuit given which is the mixed grouping, then we have to simplify the each section of the given diagram or figure. Then we can find out the capacitance between any 2 points. So let us see and solve this question. So the question is given, find the equivalent capacitance of the ladder between points A and B. So normally in this type of question, you can visualize that this is infinity number of capacitors are connected. So if we consider any section of this type of arrangement, then the equivalent capacitance is not going to change, because we can add infinity number of sections, similar sections in this diagram. So in this type of configuration, what we have to do, we have to assume that the equivalent capacitance of this ladder is suppose C farad. So if we eliminate some sections similar which are repeating, then also the capacitance will remain same. So let us consider that the total equivalent capacitance across this A point and this B point, they are suppose C. So in this question you can see this type of sections. Suppose this is one section, we can find out here. Suppose this is one section. So similar type of sections are connected in infinity number. So if we eliminate these sections, then the equivalent capacitance is not going to change. So by that concept, we can simplify this question. Now you see, suppose this part we are eliminating. So the equivalent capacitance of all other capacitance which are right side to that, let that is your C. So let this capacitance is connected across this, So let this capacitor is your value of C. So now if we find out the equivalent capacitance of this diagram, this section, then also this will come as the equivalent capacitance. So I think now you can understand, eliminating the repeating sections, we consider only one section whose equivalent capacitance will also be C, same as what we have eliminated the total capacitance. So now in this case, you can see the total capacitance of this section will be your C, and which will come out as, here you can see this capacitance and this capacitance are in series. So you know, if capacitance are in series, then the equivalent capacitance we find 1 by C is equal to 1 by C1 plus 1 by C2. So this will come as C is equal to, this will be series connection, this will be C1 C2 upon C1 plus C2. So this is for the series connection. So now in this case, this capacitor and this capacitor are in series. So the equivalent capacitance of this series combination will be 2 into C upon C plus 2. Now the equivalent of these two capacitors is also connected in parallel with this capacitor, So I can write this one as N1. So in parallel combination, you know the equivalent capacitance is added. That is, in parallel connection, the equivalent capacitance will be C will be equal to C1 plus C2, like that C3, whatever the capacitors are connected. So in this case, this is 1. So I can write this will be equals to plus 1. So now the total equivalent capacitance will be C. The section what we have considered, that will also be having this total capacitance. So this is equated now. Now we can solve this one. So this will come as C equals to 2C. This will be LCM will be C plus 2. So this will be equal to C plus 2. So this will come as 2C, C. So by cross multiplicating we will get C square plus 2C equals to 2C plus C plus 2. Now this will cancels out. So we'll get a quadratic equation, C square minus C minus 2 equals to 0. Now by solving this quadratic equation, what we'll get? This C value will come as 2 microfarad. And another one will also come as, this will be minus 2 plus 1. So you will get another term that will be equal to, actually the value will come as minus 2 or plus 2 or minus 1. So negative value of the capacitance is not possible. So C value will come as 2 microfarad. So here we can conclude that the equivalent capacitance of this ladder will be 2 microfarad. I think it is clear. This is a very simple question, but you need some concepts to solve this. Thank you.